It is known as the birthday problem. So we're supposing 30 people in a room, and we want to find the probability that at least 2 of them have the same birthday. We do not want to do this directly. Directly would mean we'd have to find the probability that 2 of them have the same, 3 of them have the same, 4 of them have the same, 5 of them have, up to all 30 have the same. Way too much fun. So what we're going to do is a backdoor approach. Instead of finding it directly, we're going to find what it can't be. So what's the complement, cough, cough, of at least 2 people have the same birthday? No, because that would be that set 2. If we wanted this statement to be false, what would have to be true? So right now it's currently saying 2 or more people in the room share a birthday. Say again? No one. We want to find no one shares a birthday. If we can find that no one shares a birthday and found its complement, it'd give us this answer. So a complement can be used to find a backdoor approach. So instead of finding something directly, you're finding it indirectly. Way a lot easier. So let's see what that looks like. So we got 30 people in a room. I'm not going to write 30's dash lines because you're going to see a pattern pretty soon. That first person could pick from any of the 365 days to have a birthday on. That's the first person. But now the second person can't have the same birthday as the first person. So how many days can they choose from? Out of how many total days? Now the third person can't share the same birthday as the other 2. And how many such fractions do we need to make? 30. Totally not doing this. As it turns out, the numerator is a permutation. We saw this before where we keep going down 1. It would be out of the 365 days, we need to pick 30 of them. The denominator is we're multiplying 365 how many times? 30 times. So that'd be 365 to the 30th. So one more time, instead of finding this directly, which would be a lot of work, we're going to find it indirectly. Whatever this value is, if we take its complement, then that would give us the answer that we want, the at least 2. You get a big decimal. I got 0.7063162, yada, 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 yada. So what is this as a percentage? 63%? Yeah. I'll just take out the last ones there. Yeah. Carefully. 1 minus, you'll do 3. I would put a parenthesis to be safe. 1 minus parenthesis 365. You're going to do the NPR thing. So on your calculator, you'll hit the PRB button. 30, and your parenthesis divided by 365 raised to the 30th. Is that okay? So think about it. If you have 30 people in a room, you have a 70% chance that at least 2 of them will have the same birthday. That's pretty crazy. You only need 30 people for that to happen. Now, tasty problem. What is the smallest number of people you need in a room to guarantee, meaning 100%, that 2 people will have the same birthday? And silence. Calculator won't help you. Just think about it. How many people do you need in the room to guarantee you have 2 people sharing the same birthday? 366. Because the first 365 could have their own, and then the next person has to have one of the previous ones. All right, first off, April. Anyone? Day? Oh, no. You're not even, yeah, that's a Taurus. The correct one is Aries. Aries is correct. Yes. Not those March Aries, the April ones.